Hi ladies and gentlemen, my name is Mrs. Ramthan and today we're going to talk a little bit about the characteristics of water. So our objectives for understanding by the end of this video is we should be able to identify what elements are in water and talk a little bit about its structure, how the elements and their bonding lead to specific special properties. So to help us with our discussion today, we are going to use a model of a water molecule. So we have a water kit. So we see here that we have one oxygen being represented by the red shape and two hydrogen atoms that are bonded to it. So with this water molecule, we have covalent bonds that are holding the hydrogens to the oxygen within the molecule. And because of the way that they bond, you'll notice it has a very distinctive shape. So sometimes it's kind of nice to remember, kind of like a Mickey Mouse head, where the hydrogens are the ears and then the oxygen is Mickey's head. But you'll also notice within this model there's some kind of flat spots here, and those are going to come into play with some characteristics of how it interacts with other water molecules. So because of the way that the hydrogens bond to the oxygen, it creates what we call a polar molecule. So because the electrons within the bonds are not shared evenly, the oxygen, I like to say, is kind of greedy. It's going to pull a lot tighter on those electrons within the bond. So the red side that's representing the oxygen is actually going to have a partial negative charge. The molecule itself is neutral. There is no charge on a water molecule. But with this, it's going to behave a lot like it is charged. So since the electrons spend more time around the oxygen, it's negative, which leaves the hydrogens to behave as though they're positive. So when water molecules interact, what we see is that they then have a strong attraction for each other. That opposite charges has them pull tighter, and the hydrogen end, the white, is going to attract to that negative oxygen end. When we have an attraction between separate water molecules, we call that particular attraction a hydrogen bond. It is common for molecules that have hydrogen bonded to some specific elements, and oxygen is one of them because of that characteristic of being very greedy with the electrons in the bond. So many of the properties of water that we're going to be able to talk about relate to the fact that these water molecules are very attracted to each other. So I like to say that water molecules are sticky. Because of this strong force of attraction between the negative oxygens and the positive hydrogens of other water molecules, it holds together very tightly. Now, the next thing I want to talk about is how water interacts with other substances. So within biology, there are some common types of other substances that we can look at. One of them would be something like salt, sodium chloride, the substance that you put on your food. So I actually have some sodium chloride here in this flask. We'll take a look at this a little bit later, but I want you to notice that it has this kind of like crystal structure. So it has the little tiny grains, they're kind of shiny. All right, got white colored. And if we could zoom in and look at the structure of those grains, the interaction of the atoms making it up would look somewhat like this. They have a very orderly arrangement. This is called a crystal lattice structure. And what we see is that we have our interspersed chlorine and sodium ions. And because each of them are individually charged, they have very strong forces of attraction with each other. So an ion is different than an atom because the difference in charge due to the protons and the electrons results in an overall charge. So what we notice is if we would expose salt to water, we're going to see that there are attractions that form. So what we notice here is that things that have a charge or behave like they're charged, like something like water, which is polar, can mix really well together. So these forces of attraction, this is what essentially happens when we dissolve salt in water. The water molecules will surround the individual sodium and chloride ions. If we take a look here, we see that if I try to put the hydrogen to this part of the ion, it doesn't work as well. But when I put it next to the oxygen side, it works pretty well. That tells us that this one is the sodium ion, which makes the positive charge, because it is the negative oxygen end that's attracted to it. This one is the negative chlorine ion, because the positive hydrogens are attracted to it. So what happens is if we mix ionic substances with polar substances, they are able to dissolve them if they're solid. So right here I have some plain tap water, and we have that sodium chloride. And if I mix them together, you'll see that the salt is going to start to dissolve. So because the water is polar and those attractions can form, the water is actually breaking up the crystal lattice structure and surrounding those individual ions. If water was not so good at dissolving things, the processes that cells depend on wouldn't work very well, because many of those substances are carried through cytoplasm, which is largely water. So the ability of water to dissolve things and have things exist dissolved is a big part of life, because those materials are needed for living processes. Now, water can also mix with other polar substances. A good example of something like that would be vinegar. It is a form of an acid. It is not actually charged itself, but the molecule is polar because of the properties of the elements and the bonds that make it up. So you'll notice when I mix water with vinegar, there's no separation of the layers. They'll completely mix within each other. So like substances dissolve like, the vinegar being polar mixes well with the water that's polar. Now, one last category I'd like to talk about are nonpolar molecules. A great example of that is represented by this model of ethane. So ethane is a carbon-based compound. There are 2 carbon atoms with 6 total hydrogen bonded atoms around it. So this particular bonding form is covalent with everything, but nothing is shared unevenly. So all of the elements within this have pretty even distribution of the electrons. So no part of this molecule behaves like it's charged. So if we try to interact with this like we did with the other water molecules, what we notice is there's nothing to create an attraction between the water and the nonpolar substance. So one thing you might have noticed, especially if you have like vinaigrette salad dressings,